Hello and welcome to this Python tutorial. Today we're taking a step forward because we're going to implement a slightly more advanced machine learning model, which is the polynomial regression. And to introduce polynomial regression, I think the best way is to make the transition between what we did before and what we're going to do for the rest of this part about regression. So what we did before was simple linear regression and multiple linear regression. And as the names indicate, these are linear regressors. And from now on, we are taking a step forward in the sense that we are going to build new regressors that are not linear anymore. So polynomial regression is not a linear regressor. Then we will build the SVR regressor, which is not a linear regressor either. Then we will build decision tree regression model and then random forest regression model, which are not linear regressors either. So that's why from today we are making some new kind of regressors which are slightly more advanced regressor, especially for SVR or random forest. This polynomial regression model that we're about to build right now is not that much advanced compared to simple linear regression and multiple linear regression, because we will just add a polynomial term in the multiple linear regression equation, which you know well now. But what's coming next with SVR and random forest regression will be based on more complex theory. And speaking of theory, I think the theory behind SVR is actually fascinating. But today we will implement polynomial regression, so let's start doing it right now on Python. Okay, so as usual, we'll go to File Explorer to set the right folder as working directory. So we'll go to our machine learning AZ folder, part 2 regression, polynomial regression, and that's the right folder. Make sure that you have the position salary CSV file in your folder. And if that's the case, you can click on this little button here to set this folder as working directory. Okay, and now we are ready to start. So to be efficient, we are going to take our data preprocessing template that we made in part 1. So let's select everything here, copy, and paste it in our polynomial regression model. So, and now we just need to change very few things. So the first thing we need to change is the name of the data set. So it's not data here, of course, it's position underscore salaries. All right. And now let's see if we need to change some indexes here for the matrix of independent variable x and the dependent variable vector y. So to do this, the best way is to actually import the libraries first to look at our data set. So press Command and Control plus Enter to execute. Well imported, perfect. And now we can have a look at our data set because we imported pandas that we use here to import this CSV file. Okay, so I'm going to execute this. Dataset well imported. Let's have a look. So I'm going to go to Variable Explorer here, and here's the dataset. Let's double click on it. And now let's see what the mission is. So we are a human resource team working for a big company, and we are about to hire a new employee in this company. So this new employee seems to be great, a good fit for the job, and we are about to make an offer to this potential new employee. And now it's time to negotiate on what is going to be the future salary of this new employee in the company. And so at the beginning of the negotiation, this new employee is telling that he's had 20 plus years of experience and eventually earned 160K annual salary in its previous company. So this employee is asking for at least more than 160K. However, there is someone in the HR team that is kind of a control freak and always fantasized about being a detective, so suddenly decides to call the previous employer to check that info, that info about the previous 160K annual salary of this future potential new employee. But unfortunately, all the info that this person manages to get are these info here, that is, this simple table of salaries for 10 different positions in the previous company. So this HR member of the team runs a simple analysis on Excel or Google Sheets and actually observes that there is a nonlinear relationship between these position levels, and their associated salaries. However, this HR person could get another very relevant info. This other relevant info is that this new employee has been a region manager for 2 years now, and usually it takes on average 4 years to jump from being a region manager to a partner. So this employee was kind of halfway between level 6 and level 7, and therefore we can say he was level 6.5. So now this HR guy is getting all excited because he's telling to the team that he can build a bluffing detector using regression models and predict if this new employee is bluffing about its salary. So at the beginning the team finds it a little weird, but is kind of curious to see what's going to happen. And therefore, here is the mission. This new employee is telling that its annual salary was 160K. Let's predict if it's truth or bluff by building a bluffing detector using polynomial regression. Alright, and now let's see what indexes we need to change. So when we look at this table here, we want to predict the salaries based on the different levels that we have, and then predict the salary of a 6.5 level here. So basically we just need these two columns here. We don't need this column because it's strictly equivalent as this column, you know? Actually, it's like we already encoded the position column here, you know, by associating each level to a position. Well, the table is already encoded here, and therefore we only need these two columns to build our machine learning model. Remember, the machine is the polynomial regression, and this machine is going to learn the correlations between the levels and the salaries to predict if the employee is bluffing about its salary. So we will not include this column in the matrix of features X, and therefore we will only take this column level here. So basically, in short, our matrix of features X will be composed of only one independent variable, which will be the level column here, and our dependent variable vector Y here will be this salary column here, containing all the salaries for the 10 different positions. Okay, so then what does that mean in terms of indexes? Well, this data frame contains 3 columns: the position column, the level column, and the salary column. Indexes in Python start at 0, so that means that this column has index 0, this column has index 1, and this column has index 2. So okay, in X here we will specify that we want the index 1, and for our dependent variable vector Y here we will specify that we want the index 2. However, there is something we can improve here because, you know, if I execute these 2 lines here to create the matrix of features and the dependent variable vector, as I just did, you can see that, well, Y is a vector here, as we can see with this 10, comma, and nothing afterwards. But we can see that X is seen as a vector as well because we only specified the index 1 here. But, you know, when we build a machine learning model, and especially here this regression model, we want our matrix of features to be considered all the time as a matrix and not as a vector here. So just to specify that X is a matrix and not a vector here, we will just add here colon 2. And don't worry here, I'm not including the second index here because, you know, the upper bound of a range here in Python is excluded. But you will see that by doing that, now X will be considered as a matrix because, as you can see, now I'm going to execute this line. And now you can see that, you know, before we had 10 comma nothing, and now we have 10 comma 1, which means that now X is well seen as a matrix of 10 lines and 1 column. So it's always better to do that, you know, make sure that X is a matrix and Y is a vector, and you'll never get any warning about that or even errors. Okay, so that's it. We selected the right indexes here, so we can actually have a look at X and Y now. Okay, so here is X, here is Y. So here we have the 10 position levels, and here we have the 10 salaries associated to this 10 position levels. And our goal is to predict if this employee is bluffing by building a machine learning model that is a polynomial model that will predict the salary of this 6.5 level here, which is the level that this HR member of the team identified for this new employee. Okay, so let's do this and let's move on to the next sub-step of the first preprocessing step. And the next sub-step is to split the data set into the training set and the test set. And actually, the good news is that we won't need to do that here. And for two reasons. It's because when we look at our data set, we can see that we have 10 observations. And when we have this very small number of observations, well, it doesn't make much sense to split the data set into a training set and a test set because we simply don't have enough information to train a model on one set and test its performance on another set. It wouldn't make much sense and it would be a little ridiculous. And the second reason is that, we want to make a very accurate prediction because, it's something real we are talking about here. We're trying to predict the central element of the negotiation we are having, that is this salary of this new employee. So we need to not miss the target here, and therefore we need to make a very accurate prediction. Otherwise the negotiation could turn pretty bad. And in order to make the most accurate prediction, we actually need to have the maximum info as possible, so that the model perfectly gets the correlations of this data set. So that's why only for this time we can allow ourselves to take the whole data set to train our machine learning model. So that's what we're going to do, and therefore we're going to put all this section into comments, putting some 3 quotes here, and also at the end. Here we go. So now all this section is in comments, and therefore no training set and no test set will be created. Okay, and finally the last sub-step of the preprocessing phase, feature scaling. So will we need to apply feature scaling for our dataset here? Well, the answer is no, because, polynomial regression actually just consists of adding some polynomial terms into the multiple linear regression equation, and therefore we will use the same linear regression library that we used as the one we used when we built our simple linear regression and our multiple linear regression models in the previous sections. So we are all good. No need for feature scaling, no need for splitting the dataset into the training set and the test set. Indexes are correct. We know what we have to do. Everything is all good. We are ready to move on to the next step. And so I look forward to seeing you in the next tutorial, because we will start building our polynomial regression model. Until then,